Hi, this is Mrs. May. We've spent a couple of days looking at linear inequalities with only one variable, solving for x. Today we're going to be looking at graphing linear inequalities with two variables. So checking out solutions first, you're going to have some problems where they give you an x and y coordinate point and they want to know if it is part of the solution set or not part of the solution. So looking at the first one here, we've got 0, 0, where x is equal to 0 and y is equal to 0. What's here? When we substitute in for that x and y in this original equation, we get 3 times 0 minus 0 is greater than or equal to 2. So when you do the work on that, we've got 3 times 0, which is 0. 0 minus 0, 0, 0 is not greater than or equal to 2. So we would say no, 0, 0 is not a solution. Looking at the next coordinate point, we've got 2 and 0. So instead of 3 times 0, we've got 3 times 2 because x is equal to 2 and y is equal to 0. So we've got 3 times 2, which is 6. 6 minus 0 is indeed greater than or equal to 2. So this is, yes, a solution. So looking at the last one, we've got x is equal to 2, y is equal to 3. I'm going to write the equation down here. So we've got 3 times 2 minus y, which is 3, is greater than or equal to 2. We've got 6 minus 3. 3 is indeed greater than or equal to 2. So yes, it is a solution. So you're going to have some problems on your assignments where you need to look at a coordinate point. Remember that your coordinate points are x and y, and you're just substituting in those numbers into your inequality and solving. Next up, we're going to be looking at graphing these linear inequalities. This is quite a lengthy page. You'll want to pause the video and make sure that you write down every single step so that you don't lose anything as far as your notes. So we've got graphing a linear inequality with two variables. We've got x and y. X minus y is less than 2. Step 1 is to write the equation in slope-intercept form. Typically, you think of slope-intercept form as being y equals mx plus b. And we've got an inequality here, and we're still going to call it slope-intercept form. So as I rewrite this equation, x minus y is less than 2. Remember that we want to get y by itself. The goal is always to get y by itself. So when we do this, we could subtract out this x and subtract on both sides. This is going to leave you a negative y because you're subtracting y. Remember, subtracting y and negative y means the same thing. I want to get it into my x before my number here, so I'm going to put is less than negative x plus 2. Remember, this is you think of this as a negative x, and this is a positive 2. You can write that as negative x plus 2. But I don't like the fact that I've got this negative y, so I want to multiply each side by negative 1. Multiply this side by negative 1. When I do that, I end up with y, and I got to flip that sign. Remember, when you multiply or divide by a negative, that means you have to flip the sign. So that y is greater than, when I multiply negative 1 times negative x, I get x. When I multiply a positive 2 times a negative 1, I get a negative 2. So my solution set for this, or my solution for this inequality, is y is greater than x minus 2. So quite a few things going on. We divided out that negative 1, so that meant we had to flip our sign over, and we end up with y is greater than x minus 2. I'm going to move this video down here, and I'm going to rewrite that equation. y is greater than x minus 2. Going back to make sure that we have that y is greater than x minus 2. Because our second step is to create a function table. You sometimes call them a t-chart. And as you know, I like to use -2, -1, 0, 1, and 2. Where you're substituting in your x. Remember, x is your input. So you're going to be inputting these numbers into this equation where x is located. So our first one, we've got -2. So when we substitute in -2 for x, we've got -2 minus 2. That's going to give you a -4. When we substitute in -1 minus 2, you're going to get -3. When you substitute in 0 minus 2, -2. When you substitute in the 1 for the x, you get 1 minus 2, which is -1. And of course, 2 minus 2 is 0. So we end up with the points that we can now graph. These are some x and y location points, and we can now graph those things. We'll move this up, move this a little bit. We've got -2, -4, -1, -3, 0, -2, 1, -1, 2, 0. So make sure that you write that down. And I'm going to move this video down. We've got our step 3, which is to plot those points and draw the separation line. Dashed if not equal. What are we talking about? We are talking about that inequality sign. Is there an equal sign? Well, there's not. It only says it's greater than. It doesn't say that it's equal to. So the very first coordinate point was -2, -4. So we've got to the left 2, down 4, should be right in this area. And then we had -1, -3. And then we had 0, -2. And 1, -1. And 2, 0. Now, it says to graph it with a dashed line. So we're not going to draw a solid line. We are going to draw a line, but it's going to be dashed. Ooh, going through these points. The computer doesn't like it very well, but we're going to keep doing it anyway. I'm going to stop that because my computer's not liking it. And think of this as a dashed line. But we're not completely done yet. We have to do some shading because it says that y is greater than x minus 2. Y is greater than. So step 4 is using that point 0, 0 to help you determine if the shading is above or below the line. It says look at the original inequality symbol. So it says that y is greater than that. So if y is greater than that, we would want to make sure that we shade in this portion, because it says y is greater than that. And when you think about, before you shade, you could put in 0 and 0 and see if it's part of the solution. So if you put in 0 for x and 0 for y, and is that part of the location? Well, 0 is less than 2. That is a true statement. So that tells you that 0, 0, which is here in the middle, this origin, if that is a true statement and it's part of that solution set, then you better be shading that's part of the solution set. Another way that you can look at it is just set x to 0 and see where that leads you as far as above or below that dashed line or solid line. If that said that x, if it said y is greater than or equal to x minus 2, you would have to put in a solid line here, but because it said it just didn't have this solid, that equal to sign, you have to make it a dashed line. Your practice problem for tomorrow is to do 2 times x plus 3 times y And remember to write the equation in slope-intercept form. You have to do that first. So get that into slope-intercept form first. And then create a function table, just like we did on the last problem. Graph those points. Don't forget to shade, making sure, is it a dashed line, is it a solid line? And then we'll look at your solutions when you come to class. Thank you. Have a great day.